Okay, so let's go ahead and get going on number 51 here. It's going to be the last video of the set. Basically, just go ahead and, first you want to multiply by that square root of x so that you can cancel that on both sides. So now that's why we have a 5 square root of x, because now there's one more than there was before. Okay, and then I know this is all going really quickly. It's writing it down really fast, but we're going to go ahead and kind of explain it all the way through. So don't worry, it'll all be up on the screen here. Alright, so let's see. We're going to go ahead and next we want to divide by that x minus 1 so that these cancel. Okay, and then we get this right on over here. Okay, so from there I go ahead and work out this 1 minus x squared. I do 1 minus x times 1 minus x, and I get this whole thing down here. Okay. Now I go back through and factor that, and that's why I get everything up here. That factored is this. Messy with all the arrows, I know. Okay. So now that we factored that, we can go ahead and cancel those x minus 1s. So that's what we go ahead and do. So now we have x minus 1 is greater than or equal to 5 square root of x. Okay. Go ahead and add 1 over to each side. That'll give us this, basically x is greater than or equal to 5 radical x plus 1, and then subtract the minus 5 square root of x. Okay. So now all of that is greater than or equal to 1. So now we're basically pulling out, factoring out a square root of x, and that's what I do here. Okay. And what's left in there? We pulled out a square root of x, so this becomes x squared. Okay. And so then we set these up separately here, just like we did before in one of the previous problems. Then you'll square both sides for the top one, and we get x is greater than or equal to 1. Now we have to add that 5 over, and we square root both sides, and we get x is greater than or equal to the square root of 6. So those are your two answers there. Perfect. Alright, number 52. Go ahead and just we're writing this out here. 2/3 x to the minus 1/3, and this whole thing is just they try to complicate it and confuse you with all of the fractions and the exponents and whatnot, but don't let all that confuse you. Really, it's not too bad. We're just going to move this the second term rather, over to the other side. Okay, so we just subtract it over. Nothing crazy. We're left with 2/3 x to the negative 1/3 times x plus 2 to the 1/2, and now that's all less than negative 1/2 x to the 2/3. Okay, so I just moved that other term over to the other side so we can start canceling things out. And then I moved this to the bottom because whenever we have a negative exponent, we can just bring it down to the bottom and it becomes a positive exponent. So I did that all in one move there. Okay, now I'm going to go ahead and divide both sides by this x plus 2 to the 1/2. Okay, so what that does is that cancels it over here, right? And so I'm dividing this whole thing by this x plus 2 to the 1/2. Okay, so that makes this be just regular x plus 2, because these two 1/2s go together to give you 1. So that's really x plus 2 to the 1. And I represent that right here. So I'll go ahead and rewrite the whole thing. Okay, so we've now combined all of that. Alright, so now what I want to do is divide that whole thing by x to the 2/3. Okay, and I'm bringing that negative exponent down to the bottom to get rid of that negative. So then so now I have on the bottom x to the 1/3, and now I'm dividing by this 2/3, and that's why I get just x to the 1. Very similar with what we did over here. Okay. Alright. So I've gotten you this far. Not too bad after this. Really, we could just kind of multiply by an x to get rid of this x here, and so on. This is all just kind of algebra from here on out. I think you should be able to solve that. If you have questions, let me know. Okay, so number 57 and number 58. Okay, so let me go ahead and find these in those pictures that you had sent me, because these were kind of things that we're just going to talk about. Okay, so 57 and 58. Let's see, a highway engineer does some stuff and basically develops a formula, yada yada. So it's actually asking if the number of cars that pass by the given point is greater than 40, what range of speed can the cars be in? So it told you to graph this function, so go ahead and go to wolframalpha.com or just plug it into your graphing calculator, either way. But you'll go ahead and graph that function, and then you can see, well, let's see, maybe the function, and this isn't going to look right, but maybe the function does something like this, and hey, say 40 is like up here, right? So then you'd say, okay, well, what x values is this greater than 40? And okay, well, it starts going above 40 right about here, right? So then we'd look down and see what our x value is. So for you, all you got to do is plug that into a graphing calculator, look and see, well, where is this graph above 40, and what x values does that correspond to? Again, this isn't correct because that's not the exact graph, but I wanted to give you an example. Okay, and very similar thing with number 58. Go ahead and just graph that, and then go to 12,000 and see what x values correspond to that y value of 12,000 or more. Cool. If you have any questions, again, please contact me. Let me know. But if that's all, then I hope this helped.